Hey, it's Dr. Brad with the very first images from the James Webb Space Telescope, something I've been waiting for so long. And as part of this first batch, we saw 5 images. The first one that was released, which was of a cluster of galaxies, actually released by President Biden himself. We also had the beautiful Carina Nebula, sometimes called the Cliffs of the Nebula, which is this beautiful landscape, almost like a painting. We had another nebula, the Southern Ring Nebula, which is actually a planetary nebula. We also had Stephan's Quintet, a group of 5 galaxies kind of all interacting together, and the first measurement of the atmosphere of another exoplanet from the James Webb Space Telescope. So those who don't know about this telescope, this was built as the successor to Hubble, not the replacement. James Webb Space Telescope has a mirror that's 6.5 meters wide. To put that into scale, Hubble's is only 2.4 meters wide. And with the telescope, the bigger the telescope, the more light you can see. It's a giant light bucket. But the James Webb can also see in the infrared color, something that Hubble couldn't see. So these are the colors of light beyond the visible that you can't see with your eyes. And this thing has been decades in the making, with thousands of engineers and scientists coming together to do it. It was launched back on Christmas, and for the past 6 months has been slowly getting ready. And that was because this is so big, it had to be folded into the rocket, launched into space, and then unfolded like a piece of origami. So it's been so challenging to get it ready for this momentous day. And this day was so momentous, it's very rare that you actually get the president himself, President Biden, wanting to release the first image. In fact, you could almost say, some people are wondering, was he going to announce aliens? But no, he saw and released the first image from this powerful space telescope. Now, the first image release was of a cluster of galaxies called SMACS 0723. Doesn't have the best name, but it is a gorgeous photo with so many things happening. Now, all of these images have actually been imaged by Hubble previously. And in fact, when we looked at the Hubble image, it was so scientifically amazing. But now that we see this James Webb Space Telescope, there is so much going on, so much more detail we can see. Now, obviously, we're drawn to seeing these really bright stars kind of in the center and off to the bottom right. In fact, these stars are so bright, we notice that there's these 6 lines coming across it. These are what we call diffraction spikes. The light is actually bouncing off the struts of the secondary telescope mirror, the thing that holds it together, bouncing off into the camera. It is that bright. But what is the real star of this is this galaxy and cluster of galaxies in the center. Now, this galaxy is a few billion light years away, but there is so much mass here, it's acting with its gravity as a giant magnifying lens. It's doing something called gravitational lensing. And as we look around the image, we see these curved bits. And these curved kind of stretchy galaxies are actually galaxies behind that cluster. They're behind that cluster about 13 billion light years away. So they're towards the beginning of the universe, but through gravity, it's being magnified around and picked up by the James Webb Space Telescope. And this image literally has thousands of galaxies. Essentially every dot in this image is an entire galaxy with tens to hundreds of billions of stars that probably have planets around it, planets that probably have moons. There is so much stuff in the universe, yet it is just a smudge on the cosmic scale in terms of what's being looked at. And of course, when you look at this image, you're drawn to the idea, if there's so many stars and planets and stuff out there, is there life? That is going to be one of the big things that James Webb starts to hopefully shine on, and that is just how big the universe is, and maybe are we alone? And speaking of are we alone, one of the first bits of real scientific data that's super exciting is of the atmosphere of another planet around another star called an exoplanet. And so this planet has the name WASP 96b, and it's what we call a hot Jupiter. So it's a bit less massive and a bit wider than Jupiter, but still Jupiter size. But it orbits its star so close that 1 year only lasts about 3.5 days. So literally, it goes around its star every 3.5 days. And so by being so close, it's hot. And so James Webb took a measurement of the atmosphere of this hot Jupiter, and it found heaps of water vapor. Now, it's obviously too hot to have liquid water, which means this water vapor is contained in the atmosphere. And it's actually probably almost more like steam. It could be almost a giant steam bath planet. They even detected some haze and clouds by the moving bits and moving clumps of this water vapor. And this is going to be a huge part of what James Webb does, looking at all of these thousands, hundreds and thousands of planets around other stars to measure what does it have in the atmosphere. Is it oxygen? Is it water? And potentially even looking for signs of life directly. And this really highlights one of the big ways James Webb's going to be used, and that is through what we call spectroscopy, or kind of astronomical rainbows. You break up the colors of light into very specific colors, so specific they result or match up to certain elements or gases or molecules in the universe. And in this case, they found that it matched up to the H2O molecule, i.e. water or ice. And now this is going to be one of the huge ways that James Webb unveils the universe, is by measuring the elements of not just planets, but stars, galaxies, and everything across the universe. And the third image, and clearly probably my favorite given it's my background, is the Carina Nebula. And this beautiful image obviously is gorgeous, but has a lot of scientific things going on it. This is essentially a gas cloud that has come from some sort of old star. And over time, this gas is being condensed down, squeezed through gravity into balls to actually form new stars. It's what we call a stellar nursery. And when you look at this image, when you see all these little bumps and wiggles, these bumps and wiggles are gravity pulling new stars, quite literally coming together in somewhat real time to form the birth of a new star system. And with the power of the James Webb Space Telescope, we've been able to see subtle detail that we missed before, little wiggles and nodules that were previously missed by the Hubble Space Telescope. And because the James Webb Space Telescope can see in the infrared, it can see different things than Hubble can. So think about night vision or police-seeking vision or heat-seeking vision. Infrared light can actually see through things that the visible light can't. And in this case, it can see through the dust and the building blocks of planets. And so by using the infrared light, we quite literally saw new stars that were previously hidden to Hubble. Also released was this beautiful image of the Southern Ring Nebula. And this is what we call a planetary nebula. So when a star like our sun grows, it will turn into a red giant and then puff out all of its layers into space, kind of like a big burp or cocoon. And this creates these very beautiful images. And at the center is left with what we call a white dwarf, something our sun will be in billions of years. Now, when previously this image was looked at, we saw the star in the center, but it was always hypothesized there was actually a second star right nearby that was actually doing the action. And that was because when we measured the property of the star, it didn't quite match up. And again, with the power of the James Webb Space Telescope, by being able to see clear and different light, the second star has been spotted, kind of the culprit, actually, of this planetary nebula. And now we realize that the star that was kind of the blame one in the past will go down the path of also turning into a planetary nebula, creating an even cooler image way into the future. And last but not least is Stephan's Quintet, this beautiful arrangement of 5 galaxies. We have the one on the top, you have the one on the left, on the bottom, and kind of these 2 at the center. And these galaxies are what we're calling a collision. That is, the galaxies are actually coming together and colliding. And when galaxies do, through the massive amount of gravity, gas and stars get shot around and blown out. And through the power of the James Webb Space Telescope and looking in the infrared, we can see the shock wave, this bow coming off of this collision at the center where this red bit is. Now, as this gas is plowed into space, it will condense down and actually likely form new stars. So this is a very active area of space, and one that actually happens quite a lot, and that is galaxies coming together to form new galaxies. And James Webb has been catching it in the action. Now, a ton of people on Facebook and social media have been asking me, are the colors real? We can't see infrared, so what's going on here? Now, the answer is kinda. The data and the colors are real, but they may not actually be that true color. So when we take data through any telescope, we break it up into colors of light. We'll measure the blue or green, yellow or red, or infrared. And when we look at the individual colors of light, we just actually look at it in grayscale. It's not as interesting as it may seem, because we're measuring the brightness and intensity in that color. And then when we put the images together, we'll say, okay, well, blue is blue and green is green, red's red, yellow's yellow. But now we have this infrared color, and the infrared color is a real color, but clearly our eyes can't see it. So we kind of bring down the infrared color into this orangey red color. So the Stephan's Quintet image is a beautiful example. Essentially, all of the colors here are real, except when you see that orangey red bit. This is the infrared color that has been signed and brought down to just at the edge of the red light where we can see it with our eyes. Otherwise, we wouldn't see it. And so it's really there and it's really going on, but if we were to look at it, we would be completely invisible to it. But it doesn't mean it's not happening. There's other types of light that we can kind of relate this to. Think of ultraviolet light, right? We know that if in the summer we don't put on sunscreen, we'll get burnt. There is light coming down from the sun, hitting the earth, but we can't see it. But clearly our body does. X-rays, if you've ever gone to the hospital and had an X-ray of your bones, clearly it can see things. You can't, but it's actually measuring it. So it's all real light, it's just different parts of the electromagnetic spectrum, as we say. And I think it's obvious my favorite image is the Carina Nebula, but I really love the exoplanet science results. This is such a big question. Are there other habitable planets? Are we alone? James Webb is going to try and answer this. And the technique it uses is one that I will use for looking at galaxies and supernova, and so many people in the astronomical community as well. I hope you liked this video. I hope you stay tuned for more exciting James Webb Space Telescope science results, and make sure to subscribe on YouTube to keep up to date.